Hello, I'm Peter Wong. I work at Central right now as a front-end developer, and I'm going to talk about some of the new features coming to JavaScript, specifically some features in ES6. I did a variation of this presentation at Central, and it took about an hour, and I was a bit rushed, so it's probably going to run over a little bit, over an hour. So I'm happy if we, if someone needs to take a break, they can relate to you. Okay, I guess we'll just get started. Feel free to ask questions or point out bugs in my code. So, first off, for those of you that might not be, or just catching up on the front end, ES6 stands for ECMAScript 6, which is kind of the next version of JavaScript. Right now, we're at ECMAScript 5.1, and they're still in draft mode for ES6, so things are still changing, and hopefully a lot of the features that I talk about here today mostly have settled down, but there's still that possibility of like tweaking of syntax or small things. They've already gone through the process of saying like what's in and what's out, so all these things I'm going to be talking today is in ES6. So first off, like, why is it important? I'm actually going to start with that last bullet point. I think a lot of us worked on the web have been bitten by getting really jazzed up about like, oh, there's this great new feature, and then I can't use it until like 3 years. But with all these new features that I'm about to talk about with ES6, even though they haven't been implemented by the browser, you can still use them today with compilers like Tracer, one by ES6, and there's a bunch of them out there. The other reason why I think ES6 is important is these two first bullet points, which is there's a ton of features, and some of these features are really impactful. I kind of look back at like ES5 and 5.1. There's some new APIs, and a lot of it was good, but mostly going to be in the frameworks, hidden away from me, and it didn't really change the way I really coded. But I really feel after kind of using it for a short time and just the types of features that are going into ES6, I mean, it's really changed the way that I'm writing code, organizing my code, and I think there's a lot of opportunity for build tools and IDEs to latch on to this to provide us a much better programming experience with JavaScript. And whether you like it or not, it seems like a lot of the frameworks out there are already, in some degree, looking at ES6. I know React had a blog post way back about their future planning for the next version, and they know that they're going to target ES6. Angular, they're playing around with Angular, the next version of Angular, and all their stuff is written in ES6. Ember has already made that switch. So if you go to the repository, everything's written in ES6. So that's kind of the brief rundown why you should be listening. So I'm just going to jump right in. How this talk is kind of structured is like the first part is a bunch of, I'd say like smaller features that I think impact us on a day-to-day experience. But the second half where I talk about classes and modules, I think those are the really important ones that are not just changing the way that we write something in a function, but how we really organize a whole project. And so stay tuned for to the end for classes and modules. So starting out, arrow functions and a little shorthand, a lot less typing. So let's do a quick comparison. So on line 1 and 2, this is the way that we've been writing functions in JavaScript. And boy, for a language that wants us to use functions, and since they're like first-class citizens, F-U-N-C-T-I-O-N is long. You have to type that over and over again, so much so that you have editors that help you out. Once you start typing F, you can just hit space or something, you automatically fill it in. Now with arrow functions, they really slimmed it down. So lines 2 and 5 are basically the same. So you're defining a function that takes in 2 arguments, arg1 and arg2, and basically does nothing, right? So you fill in the function body inside the comment there. Arrow functions also come in these other 2 forms on lines 6 and 7 to even make it more compact. So on line 6, we stripped away the curly braces, and what that means is there's an implied return value. So now you don't actually have to say, call or use the return reserve keyword to say, I'm returning a number or whatever. You could just say, specify that variable or a number or string or whatever. And there's also another form on line number 7, which even slims it down, where we rip out the parentheses. So this is a form of the arrow function. If you only are accepting one argument, then you don't need those parentheses. And so it really slims down to just an arrow. So an arrow, so line 7 is like line 6 also, in that it has implied value.
So Peter, quick question.
Sure.
Are you here to tell me that CoffeeScript is dead?
Yeah. For a lot of reasons.
Okay.
Not just because of the language, but I don't know if CoffeeScript is being as maintained as it once was. Too.
That's unfortunate. I know.
So let's actually look at kind of like a real-world usage of the arrow function. So what we're going to do here in line 2 and 5, we're going to do the same thing. We're going to rip through an array of numbers and just return a new array, but with its constituents doubled. We're going to be multiplying by 2. So on the top, you can see that it's almost like twice as long as using arrow functions on line 5 here. And yeah, I did choose the form that is the most compressed, without the parentheses and without the curly braces.
That's right, because coders always want to choose longer forms.
Now, I'll say this, like, originally when I saw that there were 3 different forms of this, I didn't have very positive feelings, because working with a code base with a lot of, smart, bright minds, and having consistency is king. And if someone's like writing it this way and someone else is writing it that way, but yeah, without those extra keystrokes, I personally like it. I'll have, for me, the jury's still out on like large code bases and having, good consistent code, even though you have all these different forms. Okay, so beyond the superpower of conciseness, arrow functions also have this other superpower, which is locking down the this. And I know Bob had mentioned CoffeeScript, and arrow functions and ES6 function the same way. So at the time of declaration, the this is actually locked down. So in this example here, we're defining a greeter object that has 2 properties, message and greet. Greet's a function, and when you call it, it's going to wait a second and then print out hello world, right? And this is the key here. So if this were a regular function, so if we just do a little this, if this were a regular function, this message would not reference that. And I'm sure anyone that's worked with JavaScript for long has been bitten by this one way or another. So that's also a really neat feature of the arrow function. And I think it kind of optimizes, some of the common patterns that we do right now with JavaScript and makes them a little bit more concise. Okay, so actually let's change that back. All right.
Hey, Peter?
Yeah, sure.
For the greet function,
Yeah.
how come you can't use that arrow there?
You could. If you did this, All recording is on. Awesome. Thanks, Ryan. So that's why you can't use it there, but fine folks on TC39 that are developing this language, they also saw a way of optimizing this as well. So here, it's kind of the old way. I mean, if we kind of look back on the previous example, instead of doing function with the object literal shorthand, we could just simply do this and totally remove that. So I think with these two features, you know, it makes it a lot nicer to use functions, and it feels a little bit more like first class and a lot less typing. So that's arrow functions, and that's the object literal shorthand. Okay, so let's talk about rest and spread, and both of these deal with how do you handle a variable number of arguments, or how do you pass to a function a variable number of arguments. So let's start with how do you handle a variable number of arguments. In the old way, we had this thing called arguments, and it's never good to work with arguments for a variety of reasons, because if we have this function called double all, and we're going to pass double all, a set of numbers, and now we have to somehow get this variable number of arguments, right? So we have to go to arguments. Unfortunately, arguments, even though it looks like an array, is not an array. So we have to coerce it and make an array out of it, and that's why we have this array prototype place that I call, which you might see a lot. And finally, we can run the map function on this newly created array based off of arguments. And finally go to work and return a double of each of those elements. So now with the rest, which is this triple dot that precedes a variable name, it automatically converts all the arguments into an array. And so it's really simple, really clean looking. Also, if you don't know, really try not to use arguments even today, because it's a huge performance suck. And those poor V8 guys have spent nights and weekends trying to optimize it. But hopefully with ES6 and this, we don't have to fall into performance. And also, it's a lot cleaner looking. So let's look at it on the flip side. So instead of, oh, sorry, go ahead.
Why did they call it rest?
The rest of the stuff.
Okay. Developers should not be allowed to make things.
No, not at all. Yo. I don't know why that application is so popular. Okay, so let's look at it from the flip side. So double all accepts a variable number of arguments, and so what happens if we want to call double all, but we already have an array in hand? So in the old way, we would have to use apply, and it doesn't look that good, and it doesn't make much sense. I mean, especially if you're new to it, like apply, and then why am I passing null? Well, I actually could pass anything because it doesn't care. This sets the this, and then you pass in an array that will be used as arguments. A longer way to do this would just be to call it out, but this no longer actually handles a variable number of arguments, right? So again, it uses the triple dot, but now it's like when you're calling it instead of defining it. So that's spread.
How do you pass in this?
What's that?
You can't pass in this.
No, you can't pass on this. So you can, what do I mean? Oh, okay. So this slide kind of shows that the rest and spread doesn't have to be used just as the only argument. It can be used as like the second argument or the third argument, fourth argument. So this example, we have a new function called run with args, and what you're going to pass to it is a function, and then basically a variable number of arguments are going to be passed to that function in the end. right? And so here's an example where args, the rest is being applied as a second argument, but it could be applied as a third, fourth, fifth argument. And it's just smart enough to know that when you call this, that the first argument's going to go into this, and then the rest of them are going to go in here. So in this example, kind of does the same thing. It calls double all, and then spreads this array 1, 2, 3 as parameters.
Do you have to use an array for spreading, or are there a general enumerable type that you can use for spreading?
It's a good question. I don't know. Something I don't cover in this is that things that can seem like an array, there's this idea of like having an iterator, and you can apply this to any object. And so I'm not sure if you could do that with those types of objects that have an iterator, like whether you could spread something like a generator. I don't know. So sorry, I don't know the answer to that. Okay, another cool, fun, space-saving feature is destructuring. Again, for you that might be using CoffeeScript, this won't be anything too crazy. But without this destructuring, if you wanted to peel off all the different properties off of A, which is an object, you have to do this. So one by one, you have to grab it. A.x, A.y, Z. But with destructuring, you do this. You can do it all in one line. So here you're doing two things, really. You're saying that I want to peel off X from whatever A is, and A has to be an object. I'm going to peel that off, and I'm going to define, the second thing, I'm going to define a new variable called X. And so after that, X is 1, Y is 2, Z is 3. This also works with arrays, and this is where it gets pretty cool, because you can combine this with other things like REST. So simple case here. So now we're dealing with arrays instead of objects. Same type of thing. Instead of curly braces, now we do brackets, as you would expect. You can use the rest here. And so in this case, head would be 1, and then the rest would be a new array, 2 and 3. You can also skip 1 to 2 without having to come up with like a temporary variable name. So you just leave that part empty, and you can skip over the second one in this case. And also, you can go outside, out of bounds in a sense, and also provide yourself a default value that does not exist. And so that's kind of cool as well. So a lot of like these like little features with destructuring, rest, and spread. I mean, I think they save you time, you know, and they cure common idioms that you do a lot, dealing with arrays, function arguments, and such. This also works for nested structures too. So it doesn't have to be just a flat object or a flat array. This example is an object where you, in this case, A is an object that has a property X, and X itself is a property that has is an object that has a property Y, hello, and so you can get access to that by adding basically a colon and doing the same thing that you would have done for destructuring over and over and over again. So if you really do need to get to a nested or deep object, you could do that. Although when this does hit our team, let's not do this too much, because I mean, it could get pretty crazy.
I'm kind of confused there why it assigned it to X, because...
Oh, sorry, I screwed up there.
Because in the structure, well, should that actually be Y? That makes more sense.
Yeah.
Thank you. So that is why. All right. And this destructuring also works for function arguments as well. And that's probably where a lot of the power will come from it.
Yay.
Yeah. Yay. Especially with object destructuring, since JavaScript doesn't have named arguments and it didn't get into ES6, you can still have that feel by having destructuring. So for example, when you call do stuff, this is what I'm talking about. X equals 5, for example, right? may not be as pretty as some other languages with named arguments, but this does a pretty good job of it without writing a lot of code. All right. So what's next?
Wait, you forgot the best feature. But I'm hoping it exists, but I don't know for sure.
What?
Can you have defaults then? Like if you have a function with 3 arguments and you want to have the 3rd argument be optional, but then have a default value?
Yeah, and yeah, we had a default argument here, but yeah, you can also do the same thing for objects. So if you didn't supply a y, then that's going to be 6, and if you didn't supply a z, then that's going to be a 7.
Sign me up.
That's also great.
That's all it's like destruction. Oh.
As soon as you mention defaults, it's like, all right.
Is any of this supported in like a node?
Yeah, you can compile down to regular ES6. Maybe some of the non-stable branch you might be able to turn on some of these things. When you start Node, there's a way, like you could do like that. You can pass in V8 options like -- harmony or something like that, and then it'll allow some of these ES6 features. So yeah. So yeah, you can get around having to compile it. Some of these features might be built in, but just hit under flag. All right, classes in a prototypical sense. So no, JavaScript didn't introduce a new type system, but it provides a really nice like syntax sugaring to make dealing with prototypes a lot more bearable. I mean, this is kind of what I'm talking about. So right now, if you want to encapsulate, in this case, a thing that has a member function called doStuff and has a constructor, you gotta kind of write this kind of weird-looking code where you define the constructor function, and then you access this thing called the prototype, and then you assign it different functions or variables or whatever that's going to be available on all instances of things. So you call this function using new, then it acts like a constructor, and it will inherit all. So this thing the thing instance that's produced will inherit all of these things that you put on prototype. So and I said hello world because the console.log kicks in from the constructor, and you also get you can use instance of to determine whether that thing is a particular class. So with the new way, we actually have a class keyword. So if we kind of do a comparison here, instead of kind of really breaking up the constructor, and on the outside of that, that's how you define all your members of that class. Everything's all well contained inside of this class block now. So a constructor is that special member that will be called when you call new on it. And you may notice some small things. You don't need a comma. So I don't know why they made it different than object literals, but they just decided to. So that's one key difference between object literals and the class body, is that you don't have to have commas. Right. And so these two, this and the previous slide, they do basically the same thing. They define a thing that has a method called doStuff and a constructor that calls console.log. Now, let's talk about inheritance. So, the next two slides, I'm going to show like how you can implement something that satisfies this in current ES5 versus the new ES6. So we want to end up in the next two slides with a child function that you can call new on it, constructs a child that is an instance of another function, constructor function parent, and also instance of child itself. And when you call the constructor of child on line 2, it's going to call the constructor on parent. And then on line 8, it's going to have a doStuff method, which is also going to call its parent. Now, I mean, like if you're doing this in Java or Ruby, this would be easy peasy. But right now in JavaScript, this is what you got to do. And now bear with me, because I do want to emphasize how painful this is. Line 1 and 2, pretty simple. Okay, kind of what we covered in other slides. Define constructor, add stuff to its prototype, so that all instances of the parent will have a do stuff. So it starts getting interesting. Now you're defining child, this constructor. Now you have to call the parent constructor, because that's what we want. So you have to know that ahead of time. So parent.call this. So you can't just call parent, because it would operate on the wrong this. And so you've got to lock in what this keyword is, because if the parent starts attaching stuff to this, it will blow up. That'd be fun. Next thing, okay, you need to do some acrobatics to get the prototypical chain correct, so that if you knew of a child and you call something that is available on the parent, that it can actually find it. And so that's what all this work does. Object create, that's in ES5. We're going to create a new object that is based off of parent.prototype, or not based off of, it's going to make it so that the prototype of the created object is going to point to this. Now, the second argument here is going to be defining all the different members on this new prototype object, and it's just awesome stuff.
It's really not the same, you know that, right?
What's that?
It's not the same.
What do you mean?
Well, for instance, I'm going to pick on Ruby because that's my data.
Yeah.
A child doesn't necessarily need to know what's in parent to have it accessible. Where here, you're kind of coding it twice. It's not even really dry.
No. Yeah, you're absolutely right. Yeah, because like you need to. So it's not only it's a lot of error-prone code to write, but it's a nightmare. Let's say we want child to extend not from parent, but from another object, right? Okay, so I got to go change that one, whoops, that one, and then that one, right? Where you really just want to say, extend from a new parent, not have to go through, and this is a really simple use case where there's only one method, one constructor, and like if we had a bunch of different functions, you have to go through and change all those, right? So it's just not fun. And even after you do all this, it still wouldn't be right, because line 5 would not work correctly. You wouldn't have instance of child, and so that's why this one line down here that you can't see, which will only refresh. Anyways, it's error prone, and it does. And when you look at this code, at least for me, it doesn't jump out that this parent is child, and child is extending off its parent. Whereas in ES6, okay, so just the keyword alone, defining class child that extends parent, that already does all the acrobatics that we were seeing about messing with the prototype, creating the prototypical chain just correctly, just all that. And then the other cool thing is now we have this new super method, and that automatically finds parents. So then, kind of going through that use case of like maintenance, like if we wanted to extend, from another parent or whatever, that's it. I don't have to go find all the places where I call super, and or basically I need to call into my parent to do my work. So
if you don't, and in line 11,
yeah.
if you don't define do stuff, does the child still have access to the do stuff method?
Yes. Yeah.
Okay, so it automatically extends all the methods.
Mm-hmm. Yep.
So, similar question. On the previous slide,
Yeah.
you had to, line 10, that block was necessary so that do stuff got called with the right this for the child instance?
Okay, so another way, I guess, you could do it. It's just trying to use object create in its glory. Another way you could have done it is if you just did prototype. If I could type prototype dot do stuff equals that. Not, but that depends on what you want, how to do stuff. The object create and all that junk here. These are new in ES5.
Yeah.
Yeah, where, you know, do you want it to be enumerable? Do you want someone to be able to write on top of it configurable?
But if you skipped the passing in of the do stuff, wouldn't it just dispatch up to the parents do stuff?
Yes. Yes. If you didn't have line 10 through 21.
So that's only if you want to override what the do stuff method does in the parent.
Oh,
Exactly.
Okay, got it.
It's not a necessity.
No, it's not in the
Oh,
subject.
okay.
Oh, shit. There we go.
So now, underneath the covers, the much nicer new kids one, is it pretty much doing all the ugliness that, so the
Yes.
ugliness is still there?
The ugliness is still
It
there.
just hides it from you.
It just hides, at least like for, like, if you're compiling it, it's probably going to compile it down to something like this. But eventually when it's actually implemented in the browsers, will probably be able to take advantage of a lot of different things, because it knows that what you really intend to do. Whereas this, I mean, it's tough to figure out, like, well, child has do stuff, but that person had to call object that create, you know, I'm trying to think of, like, if I'm, like, writing the VM, like the V8, and then I have to, like, handle all these, you know, special cases and such. So if you're defining it in a way that is more of your intent, you know, instead of breaking it out into multiple functions, which would be really hard to, I mean, not just for me as a programmer to see, but also hard for the VM, like V8 to see. So, okay. So another thing that we'll be able to do with ES6 is be able to do private members a little bit better. Kind of depends on how you look at it. So what we want out of this is we want a greeter class that has a greet function that in turn calls a private function that is not available outside of this, so you can't hack into that, right? And a common pattern that we see a lot is we'll define that private function inside of the constructor. And basically, because you've done that, you've used closure so that only anyone inside of any code inside of the constructor can actually have access to it. And so here, not only we define the private function, but then we attach this greet function that's going to be actually accessible from the outside world that then in turn calls that. And I mean, this is a very trivial example that does nothing, but I mean, if you work in Java or Ruby, I mean, having, you know, that explicitness of saying, like, this is private and this is, you know, public, you know, it makes it a lot easier to, you know, work and maintain that code, knowing that this is like the public API. I should be able to call this versus something that, you know, you can't. Ta-da! This is how it is in ES6. Define a symbol, and then you do a create a computed property key, and then you call that. Okay, this is not what I wanted. I don't particularly like this, and I remember when I did this same talk at Central, just like ended up being like a 10-minute like discussion of like this sucks, and yes, I understand. Okay, so to actually understand this, let's take a quick detour and break this down, because really what's going on here is a number of other features. So one of the features that private members is using is this idea of computed property keys. So the idea is that, let's just look at the old way. If we wanted this new object called old way, but we want to define a key in there, but we don't know if, like, at the time that we're actually programming, it's like dynamically generated. So it's based off of this variable, and you stick these together, and then the key is going to be Fred, and the value is going to be Flintstone. With this new ES6 feature, we can still we can do it in one statement while we're defining this object. But in the place where we're giving that property a name, we use the square brackets. And then inside of the square brackets, then we can have any JavaScript expression that, you know, it can just be as simple as doing this. It could just be a hard-coded value, just like a string, could call it to a function. And so that's what computed property keys does, and it achieves the same thing, so that if you did oldway.Fred, you get Flintstone, newway.Fred, you get Flintstone too. But in the bottom. In the new way, you can get it done in one statement.
I don't think I like that.
You don't like that?
No, I mean, I really dislike it when languages use symbols for like 20 different things,
Yes.
right?
Yeah.
It just doesn't make my life any easier. So,
Yeah. When you're parsing through it.
Yeah,
Right.
it's when you're quick, I mean, visually for me, when I scan through something like that, I see square brackets and I think, oh, right, or whatever, right?
Right. I agree. Next thing that is part of that private members example is the usage of symbol. And a symbol generates a unique identifier, and that's about it. I can't think of any other uses that you would use symbols for. And so, in combination, when you use the computed property keys and a symbol, you get this. I don't know if I like it.
Why don't you find a symbol outside of the class?
Because you have to. Because otherwise, you'd have to expose that some other way. So I think the idea is that this is going to be inside of closure anyways, right? So I don't think it's any
use
better.
that symbol in multiple classes then?
Yeah, you could. Yeah, and so I mean, some may see that as like, well, that's not true private members, because then you could, like you said, use that for multiple. But then it's like, well, that could be cool too, you know? Sounds dangerously awesome. So you define a symbol which is unique, right? It's not a string. So someone on the outside can't just come up with the magic string to access Greek info, because they won't have access to symbol, this Greek info. So it's anyone that has access to that can call this private number.
But couldn't they just enumerate your properties?
You can't. Symbols, so properties that have a key of a symbol are not enumerable.
Oh, okay.
So you won't have access to that. So you can't just do object.keys and like, aha, that's the one. Unfortunately, like I think like in the last minute, like they added another function that allows you to find all the symbols for an object. So it just kind of, I was like, what the fuck, guys? I mean, like, sure, you won't know which one's which, because you'll just get a long list of symbols.
Yeah.
But anyways, just so you're aware of, you might start seeing code like this. I'm not terribly in favor of it, but you know, I would have liked just a nice private keyword, but whatever.
I mean, that problem's been solved like 4,000 times in
Yeah.
every other language under the sun. And it's funny that they decided that everyone else who came before them was stupid. And they were going to come up with a brand new way.
I'm not going to speak for them, but I think what they were fighting is like, okay, let's say we even had private keywords.
Did JavaScript have the notion of a private method?
No.
Yeah, that didn't.
No, I think this is kind of a toughie problem, because, okay, let's say you were able to do this. Right. Fine, awesome, cool. It looks exactly like, oh, without this guy. Now, if I'm on the outside, like some other code, and I do this, and I call greet info, how does it know I shouldn't have access to it?
Because you designated it as private.
But, I mean, like, just because of the dynamic nature of JavaScript, like, okay, so it's like, you would have to keep track of call sites, right? It's like, where are you calling from? Are you calling from within greeter, right? And what happens if then it gets really problematic, like, when you, like, dynamically add.
I think you're overthinking it. I think in this case, it could go ahead and have the internal symbol in the class and just hide that nonsense from you here.
I would think so.
That's
Yeah.
I mean,
I try to follow some of the discussions that they had on why. I mean, this was a really heavily debated thing. And, you know, I didn't think ES6 classes were going to make it in. But, you know, there's a lot of compromises. And from what I gather, this was kind of a compromise for implementation,
the people
which doesn't help us.
Yeah, the people who decided to do the private this way with symbols really need to get out and program in another language, something other than JavaScript. And it's a good thing, trust me.
Yeah.
That's what we have ES7 and ES8 for, to go fix
fix that. They keep doing that though, and it's not getting any better.
so grateful that they did that.
I think this might be the first language update I've seen where actually not just once but twice things got worse. Which is,
There's some forward movement here.
there's forward movement.
Yeah. That one, yeah.
That one and the other one.
Unnecessarily.
Yeah.
Yeah. And and I think really hard about it. I'm like, should I just leave this out? Because, like, even at Central, it's just like, blah, 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 blah. I'm like, I'm not going to be able to defend that.
Well, no, but
But
it's nice to know that it's gonna be out.
exactly. So if you go and see this, like, that's important. Like, what? Oh, it's doing this. I don't like this.
We won't personally hold you responsible
Right.
for it.
Well, thank you.
So, okay, modules, sane code organization. Now, everything I've talked about until now, at least this is where I interject my personal opinion, if we threw out everything out and just had this, I'd be very happy. Because this is my reaction when I heard about this. Whoa! And a lot of it comes from this. It's like, okay, like, meanwhile in Java, we have an import statement. Cool. That's how I can say, I depend on this, and you go and figure out how to load it. And I don't have to deal with that. We've got this. Just do simple require. JavaScript, we have this. Yep. Yep. We have this, right? We have to run to HTML to load code, right? And once we move over to HTML, now we've kind of, I mean, from a maintenance standpoint, you know, here's my code that has this dependency. Now I got to go over here to HTML and define that dependency. It's not good, and it's a problem because these are all the different ways that JavaScript developers have tried to solve this problem in user land, right? Sometimes we just go to the server, say, server, you figure this out, right? That should look familiar for the Ruby on Rails people with the asset pipeline. Node.js people figured something out. Again, on the server side, this is AMD, EXTJS. These are all solving the same stupid problem, right? And it's something that, you know, this is my favorite. You just roll your own. It's going to create that script tag and inject it right then and there, right? So these are all solving kind of the same problem that is built in other languages. So that's those two other slides, like in Java and Ruby, but we just don't have anything in JavaScript.
Please tell me that last one's just something you've done and you've never seen anymore.
I've never seen that. So how does this work? So yes, finally we got our own import statement. Bam! And it's built into the language, and it's not something that we have to depend on the server or some like third-party library. So actually, let's start with exporting. So let's say we have a file source parent.js. You consider that as a module, and everything that you put after export is going to be exported. Pretty simple enough. And then the way that you import it, we'll start from this side. So you say that I want, you know, where am I going to get this module? /parent. They just happen to be in the same directory, right? And then what do I want out of that module? Okay. Remember destructuring? So you can, and I'll cover this in the next slide, you can export many things. So you can enumerate all the things that you want to bring in. And so that's the name of that I want from this module, right? And then you can do stuff with it, like then use classes. If you don't want to have those curly braces, if you know this module is only going to export one thing, you can tack on a default, so that you don't have these curly braces. Like I alluded to, you can have a module that exports many things, and so now it's no longer parent, but parents, plural, and I'm exporting two classes, parent and another parent. And that's, in this example, it makes more sense why you have the curly braces, because now you have this enumeration of all the different things that you can import.
I'm assuming that parents is nothing more than the name of the file plus .js, right?
Right.
Like you could have called that, you know, automobiles, and as long as there's an automobiles later in there.
Automobiles.js, yeah. Yep. Okay, so that's one thing you touched upon, like it automatically fills in .js. That's also kind of being debated, so that might change. I know some of the implementers aren't terribly thrilled with it. Okay, so the other thing, and this,
So you can't use like parent.class, implement your class file? It's always got to be
has to end with a dot JS.
JS.
Yeah, yeah. We'll just leave it at that. So this will appeal to probably some of the Node.js people. Anyone do Node.js? Not a single one. All right. Anyway, so what happens if you want to import the whole module and be very meta? So they introduced this very recently, maybe in the last couple weeks, is that you can say import star and you give it a name, and you can kind of treat that like a namespace. So now when you reference things from this module, use that kind of namespace kind of field, parent stuff, parent stuff, another parent. And also with this in hand, you know, you can do very meta things, like you can interrogate this one object and see all the things that it exposes at runtime without needing to know that, you know, as you're writing it. So could be interesting. Now I'm not going to go too far into this because this would be a talk in itself. Behind all this is a module loader API. So I mean, this is like great on its own, but this module loader API will allow you to basically control how modules are loaded, like where. So like when I say like dot/parents, what does that mean? You know, where is dot? You know, by having this API, you could customize it. And let me. This sounds very academic, but some use cases would be not only changing like where things are gotten from, like let's say for a test environment versus a dev environment versus staging, you might want to change like where you're getting jQuery or where you're getting a certain dependency based on of a certain environment. So you could do that there without changing any of your code. You just change the module loader or, you know, tweak some of the options. Another thing you could do with this is you could load up not just JavaScript. You could load up CoffeeScript or TypeScript or, you know, maybe a big binary blob of something. So this module loader API allows for that. And also, there's an async API. So up until now, like this statement, that's done synchronously. You know, until each of these, until this module has been fully loaded, nothing else gets executed, right? But maybe you want to have that control and you know, load up a bunch of things asynchronously for performance reasons or whatever. And this module loader API does allow for that. So very cool stuff.
Has the asynchronous API been fleshed out?
Yes. And we'll actually see a little bit of it, but I mean it's pretty. Kind of just going a little bit more in depth about that. It allows you to change. It allows you to specify your own module loaders. I don't know if people that work in Java have ever tried to create their own class loader. It's kind of very similar. Allows you to change the different stages of loading a module. So first question, where to get something? You know, I've given you a string, dot/parent. What does that mean? Translate it to an actual URL. So that's one stage. Another stage is like to normalize that. Normalize all the paths so that you can do deduping and stuff, you know, because like maybe you're in this one folder and dot/parent means the same thing as dot/parent in another place, right? It also allows you to do transformation. So you go get the thing, you know, it doesn't have to be using XHR. Maybe you're just grabbing something from local storage or something from a WebSocket. So allows you to change the medium at which you get a module. And then, and then the last part, the transformation part, is that, you know, maybe it's not a JavaScript module, but can you transform it into something that can be made available to JavaScript code? So in the case of like CoffeeScript and TypeScript, they would use this transform stage to do the compilation process itself. So it loads in the text of the CoffeeScript, transformation goes through, runs the CoffeeScript compiler, and then ejects the JavaScript object. So that's kind of what's going on with the module loader API. Cool. Now, how's everyone doing? Do I need a break? I have just a little bit left where I was just going to go through and show how you can use this stuff today. Should I just keep going? All right, keep going. All right. Bob says keep going.
I mean, there's more votes than just mine, but mine is.
It's Bob. All right, so the tools I'm going to be using is Tracer and ES6 Module Loader and System.js. So a little bit about Tracer. That's the compiler. So it'll take your ES6 code and then compile that down to something that even IE9 can understand. So it'll take all these features and try to boil it down to ES5. That's what it does. The next few things, I guess, are optional if you don't want to use modules, but I don't know why you wouldn't want to use modules. These are polyfills and shims for allowing you to have the import-export statement, and also polyfills, that whole module loader API if you need that type of power. All right, let's see how this goes, because I just slammed this together like right before.
When's the rough estimate supposed to happen without being compiled?
Without compile?
Yeah.
Who knows?
So we're probably talking at least
A year.
and a half out, probably.
Yeah, yeah. I would say that. Yeah, I mean, like, okay, well, if I were to go down the list, like, modules, I haven't seen anyone start implementing this. Classes, the V8 guys just started working on it last week. Rest and spread are in Firefox. Arrow functions are in Firefox and briefly landed in Chrome, and they got ripped out because some bug. Yeah, so I mean, that's kind of the brief, at least as I know of it right now. But if you compile it, you can use it today.
What is JavaScript under the W3C?
No, ECMA.
Yeah.
Yeah.
Went to ECMA to escape from Microsoft, but it didn't work.
But it
The thing
didn't work.
Microsoft does all of them.
Yeah, and then.
It's like that little kid in school you can never get rid of.
Okay, so I set up this project, and it's just kind of just to show that it doesn't take too much to start using this. Hopefully, are you guys familiar with, well, since no one raised their hand about Node, NPM is their package, thank you, Ryan.
Just name for Node Package Manager.
Yes, Node Package Manager. And so I'm going to be using that, and I think that's where a lot of the front-end development is going on, is either in putting their stuff available through NPM or at least Bower. So first, so I set up this project, and to specify those external dependencies, you NPM install these three things. Like I mentioned, Tracer the compiler, System.js, and ES6 module. Those are polyfills for working with modules. Once you have that installed, and this is nothing specific with ES6, but just Node and front-end development, you'll get a Node modules directory with all the things that you asked for once you run npm install. Now, here's the good part. Let's start out with a really simple HTML file. Things that you'll need are basically requiring a JS file from each of them. The tracer runtime, those are kind of like the polyfills for ES6 features that aren't module related, and then these two lines are the polyfills for that.
It's ironic that, of course, to get them in, you have to go back to including them via script tags.
Well, this is for like if you're using it in a system that doesn't have ES6.
No,
Right,
it's just there's an irony in it.
Yeah, definitely. Yeah, in the future, like there's some, and I don't know, I haven't kept up, but there's supposed to be like a module tag. Then you would just say like my module. But for the time being, yeah, I mean, to like bootstrap this whole thing, you need to use this script tag to add all the polyfills that enable the good stuff. Now, this is something specific to module polyfill. You can read, this approach I'm taking is right off of ES6 module loader. If you just Google that, ES6 module loader GitHub, it basically explains what I'm doing right now. And this bootstraps the default module loader, which is the system. And so that's what this is. And then finally, you want to import your first module, which in this case is app. So what does app look like? So we're going to go into source. So this is all ES6 code is inside the source. And then we're going to build these files into a build directory. Okay. So what this simple application is going to do is render, it defines a person module, good buddy pal of mine, Ryan Gary, and it's going to define a view and render itself to the page. That's simply what it's going to do. And I wanted to do something that has multiple modules. And in this case, we have a models module using that import statement that we were just talking about, and importing a view. We can take a look at that. So starting out with the models module, we're exporting one class person module that's just going to assign some instance variables, first name and last name. And then for the views module, kind of backbone-esque, something that takes in a model and has a render function, and it'll do something. It'll create a DOM node that can then be attached to the document. So we can see how that's actually being used in the application, which is the first module to be loaded in this example. So we're using person model. We're going to new up person model. His name's Ryan Gary. And then we're going to create a person view, passing in that model. And then we call that render function that we had defined here. And then that produces a div element, something that can be attached to the document. So now, right now, I mean, again, since a lot of the browsers no browser has modules implemented, we'll have to compile this down into some form that allows current browsers to actually access that. So that's where Tracer comes in. Bam. All right. So we installed Tracer, and part of that is an executable that runs the compiler. And with that compiler, you can pass in a bunch of options. As Tracer, a little bit of the background behind that is people funding Tracer is Google. They have two guys, Eric Arvidsson and John J. Barton, working on that. And I think it's being used as kind of like this test ground for ES6 features, right? Before they go headlong into implementing it into the browser, where it's really costly, and especially costly if they screw up, let's create a compiler that allows people to use it today and basically hit all the rough edges so that we don't have to. So they created this Tracer compiler and allowed the person using the compiler to really switch on different features. Do you want modules? What format do you want that modules to be compiled to? Do you want async functions? Do you want classes or whatever? Right. Since ES6 has been kind of all the features that are going to be there has been kind of set in stone. You don't have to put so many configuration objects. It just knows by default. You want classes. You want spread. Modules and stuff like that. So we're going to run this function and command line. And this runs the compiler. And the interesting thing here is saying that when you compile modules, you want to use this type. Okay. And I don't know why they call it instantiate, but they just do. And this next part is saying, take all the modules inside a source and then compile it to a different directory called build. So once we do that, have it so quick, we can look into the build directory. So let's close all these guys down. You can kind of get some insight on how this is all being compiled. So let's bring up, so you can kind of see the before and after. So this is what it's doing behind the scenes, hiding that ugliness, so to speak. So you have the ES6 module code on the right, and then what it compiles down to over here on the left. And so you can see it does generate quite a bit of GORP to get the module stuff correct. But anyways, when we actually load this up, load up the index.html, which I'm serving through a simple HTTP server, hopefully on localhost 8081. Oops, 8080. Hooray! So it actually loads up these modules, and it actually let me close this. Loads up the modules, and you can see that on the network stack that it's actually doing its thing. It's actually loading. We told it to load the app, and then it knew, through module dependencies, knowing that I import something else. App imports models and views, so you can see that those two loaded, and then it actually made use of those modules by newing up a person model, and then newing up a person view and executing its render and attaching that div to the page. So, yeah, that's basically it. All I had. Those are the tools. There's much more that I didn't cover from ES6 and also ES7. Two things that actually have made it into Chrome right now is map set and weak map and weak set. How that's going to change your life as a JavaScript programmer is that we've abused object so much. We've treated object as if it's a map, but there's implications to that. So now we actually have a first-class map and set types, and along with that weak map and weak set, which makes it really powerful so that if you want to do some form of caching, because two of the hardest problems is naming things and cache invalidation. So weak map allows you to store stuff, and once it's the last reference, then it just goes away. Object observe, also something that just made it into Chrome. Mostly probably will use by frameworks, but if you want to track when an object is changed, efficient, without doing some crazy form of dirty checking like Angular does, object observes there. Promises will really help us get through asynchronous codes without writing horrendous corps of callbacks and whatnot. Generators are also very interesting. Template strings allows us to do string interpolation and then some. Block binding, if you've ever done something like, okay, so let's just write in here. Or actually, a better example is var a less than 10, a plus plus, and what do you know? A is available outside, right? With block binding, you can do this and make sure that A is only available inside of that for loop. The same goes for ifs and such. It basically takes out that. I know I've said a couple of times like the idea of variable hoisting, so that even though you declared it over here, it actually declares it, in all intents and purposes, at the top of that function. So that's what block binding is. And finally, there's a whole host of new functions that they've attached to object array, number, and math functions. If you want to stay up to date like I do, there's a ton of places that you can check. The current ES6 draft, I'll make this available online because there's links to these. ES Discuss, that's how you can kind of get a pulse of like what the TDC 39, the people developing this are kind of talking about. And they also get some great talks from the people trying to implement that from Chrome and Firefox. And so you get a little bit of insight of, well, they're probably going to throw this out, they're going to change this, they're having problems with this, as ES6 is still kind of in flux. ECMA 262, this GitHub account, kind of shows you their process. So for things that are like past ES6, ES7, ES8, you can kind of get a feel for what's next and how far along are they. So some examples like async functions and generators and such.
I think I know what TC39 is. That's like the committee number inside ECMA for JavaScript. What's 262?
I think that's the actual designation of JavaScript. Yeah. And then a bunch of people that are involved in the process one way or another. So again, I'm not going to go through all of them, but I'll make this available so that, yeah, you can Twitter follow or stalk some commits. So that's all I had. Hopefully I didn't bore everyone too much.
Aside
But
from all the syntactical sugar in ES6, are there speed improvements, performance improvements along with that? No, always benchmarked it or?
well, I mean, it kind of like depends on the implementers, right? And they're not far along. So I mean, like map, for example, is probably going to be way more more performant than you using an object, misusing an object as a hash, because you know they don't have to be worried that this object is actually a type of this, and anyways, yeah. So I mean, there's some things like inherent, like map that's set because they're reduced functionality that probably, yeah, you're going to see, you know, good performance right off the bat. Tougher things, like bigger things, like, you know, classes and such, you might have to wait because I think they'll just want, the implementers just want to get something out the door before they start implementing certain performance features.
So, have you seen things being developed in a tool chain like Run Tracer or anything that does the normal productionalization stuff like concatenating of the JavaScripts that you serve, or would you just pipe that to standard like ES5 pipeline?
So moving into production, like especially the modules, like where it's yeah. So what I've done is, I just compile all my modules and just smash them together, right? And you know, I think that's roughly what I think some people are doing right now. I know there's some other build tools that are a little bit smarter. They don't just like take all the modules in the folder or nested directory structure, but actually read all the dependencies, only grab the things that you need. Yeah, so I think there's a lot of opportunity there for build tools to get smarter. Cool.
Any other questions? Thanks very much.
All right, thank you.